Okay, so today we're going to talk about horizontal stretches and reflections. And so if I look down here, I'm given the green dotted function. So this green dotted function is the square root of x. Okay, it's a sideways parabola, or half of it. And this green dotted function has been transformed into the red function. Okay, I think we want to pay particular attention to these points here. Okay, they have the same y value, but the x values are different. Okay, same y, but their x is 4 goes to 2, 9 goes to 4.5, 1 goes to a half. So they all are divided by 2. So if I go over to, I want to be able to make this, I want to make what the equation is. So I want to determine y is equal to what equation here. Okay, that's what I want to do. So let's go over to Desmos and play with it a little bit. Okay, so here is my function, the green function is there, and I have all these coordinate points on there. If I come along and if I think I want to make this x value, I want to make it 1/2. So if I go 0.5, oh, it moved the graph, but it moved it down to here. This 4 went to 8. The 1 went to 2. That's not what I wanted it to do. So if I come back here, let's change that. Oh, back too far. So here's at 1. If I make it, if I made it be 2, the 4 becomes 2, the 9 becomes 4.5, the 16 is 8, and the 1 is 1/2. If I make it bigger, look what happens as that b value gets larger. The x values get smaller. It's going in the opposite direction. When b is 2, 1 becomes a half, 4 becomes 2. If b is 3, well, the 9 becomes 3. The 4 becomes 1.33, which this is 4/3. 1 becomes 0.33. This is 1/3. And so there seems to be an interesting relationship here. Even though its b is 2, it changes by 1/2. So can I make the equation here? Yes, the red curve is specifically y equal to the square root of 2x. So even though this x value is shrinking by 1/2, I'm multiplying it by 2. So it looks like it's the opposite scenario. Let's look at the next one here. Okay, again, we're at the green function, and I want to make it a 2. The 1, this, I want to make it a 2. The 4, I want to make it an 8. Well, I actually already did that one by accident last time. I changed the b value, and I made the b value, let me go to 0 to 1, and let's go by 0.1s this time. So as I change this, look what happens here. So as I get this number between 0 and 1, it moves out, gets pulled out this way. It's like it's going slower. All right, and so I'm looking for the value to be 4 and 8, 9 and 18, I believe. So 9 and 18 by 2, and that's what I have when I have b to be 0.5. So the equation here of the red one is y is equal to 1/2 x. Okay, and so what I want to do is, can I generalize these results? Well, this b value, if I wanted the x to be twice as big, I divided it by 2. When I wanted the x to be half, I multiplied it by 2. So it's the opposite operation what you would expect. Okay, so if I'm going to generalize it, what happens is my xy value turns into, well, it's not x over b comma y. Because if I go x over 1/2, that's the same thing as saying 2x. That means it's going to be twice as big. And so the b value, and so what this is called, this is a horizontal stretch. Horizontal stretch by not a factor of b, by a factor of 1 over b. Okay, so I don't do b, I do 1 over b is what the factor is. So when I look at this scenario here, I'm going to be stretching it by 1/2. I'm going to stretch it, a horizontal stretch, by half 1 over the b value, which is 2. And so the x value is multiplied by 1 over 2. And that's our horizontal stretch. This horizontal stretch is by far the hardest transformation we'll do all year.